Hi, welcome to this short screencast which is going to talk you through how to calculate a sample size for a study that's aiming to estimate a single proportion. The scenario that we've given you, as you can see here, is that we want to determine the proportion of bobby calves that will be dehydrated when they arrive at the meat processing plant. We've gone on to explain here that how it's going to be measured, and the percentage of calves that will be dehydrated is unknown. However, you've had a chat with some people and they estimate that the expected number will be around 20%. The people funding the study want you to estimate the true value within 5%, plus or minus 5%, and they want to be 95% confident. So we're seeing that standard value of 95. So now let's look at how we deal with that question in a sample size calculation. Okay, so we go to the AusVet sample size page, and as you've seen in the screenshots previously, there are a lot of different options available to you. You're going to click on the one to estimate a single proportion if that's what you're aiming to do. When you open the page, you will see it asks you to give 4 pieces of information: the estimated true proportion, the desired precision, and the confidence level. Now, if you recall in the example, the estimated true proportion, we don't know for sure, but our discussion suggested that it might be 0.2 or 20%. We wanted to know within plus or minus 5%, so that's the desired precision, and we're selecting a 95% confidence interval, which is fairly normal. Now there's a fourth thing here which we haven't talked about before, but it's the population size for finite populations. Now if you're just sampling and there's a really large population, you don't need to worry. But if you were, say, to go on a farm and you have a fixed number of livestock units on that farm, well then you might want to do that. But if you're just going out into the population in general, so for example selecting from a number of farms, you can just leave that blank. We hit submit and we wait, and you can see here that the population size we require is 246. Now the really neat thing about these calculations is that you can also see what would happen if you were to change the prevalence and if you were to change the precision. So here is the value that we were looking at, the 5% precision, and you can see the highest value is when the apparent prevalence is 50%, and that's true at every precision. So the take home there is, if you do not know what proportion will have the outcome that you're looking at, assume it will be 50%, because that's going to give you your largest possible sample size. Now you can also download the Excel files results and look at them at another point in time. So this concludes the session on how to estimate sample size when the outcome is a single proportion.